All right, we're working on 423, enlarging and reducing ratios. Enlarging and reducing ratios. In the past few lessons, you've enlarged and reduced images while preserving their shape. By doing so, you created similar figures. You learned, for example, that to enlarge a shape to 300% of the original, you would multiply the length by each side by 3, because 300% is 300 per 100, right, which equals 3. If you want to compare side lengths of similar figures, one way to do that is using ratios. A ratio compares lengths by dividing. In this lesson, you'll learn about using ratios to determine whether enlargements or reductions were done correctly. As you work with your team, use the questions below to help start your discussions. Daphne wants to make Zug by enlarging Mug, but she doesn't have time to graph all of her points. Her friend Michelle shows a clever way for making the enlargement on a copy machine. Michelle wants to make an exact copy of Mug, so she copied the picture at 100%. Daphne wants to enlarge Mug so that the copy is 2 times larger. What percent should she enter into the copier to make Mug 2 times larger? Well, if I go back up here, right, and we think about what 300%, that's 300 per 100, and that equals 3. So then what would I do if I started with a 2, right, and I need to work backwards? I need this to be over 100. Well, it's got to be 200, which makes that what? 200%. Okay. Robert wants to shrink Mug so that it's 3/4 the original size. What percent should enter into the copy machine? Well, what we can do too in this case, I'll try a different approach for this one, is we could simply figure out which one gives us 3/4. So this is 250 over 100, right? And this one, with a little bit of reduction, 25 out of 100, I divide it, or 10, I divide them both by 10, but I could do it by 5 again. But what we should recognize is this is not getting me to 3/4. We already determined that this is 200 over 100, so that's 2. That's not going to work. This one's a 150 over 100, so that one would, hopefully we see already, is going to be 1 50/100. That's not going to work because that's not 3/4, right? We already know that that's 1. So 75 out of 100 is... All right, with some division, we do get to our 3/4. There we go. Suppose an 8 by 9 rectangle is enlarged 300%. What will the side lengths of the new rectangle be? All right, well, 300% means it's 3 times bigger, right? So what would be 3 times bigger the 8, right? We would have 24 centimeters by... What's 3 times the 9, right? That'd be 27 centimeters. How many times larger are the new side lengths compared to the original? Well, that's 3 times larger, isn't it? 3 times larger. A coach took a digital photo of her runners finishing a race. She sent an 8 centimeter by 12 centimeter photo to each runner. So there's my original picture, right? Looks like there's a copy there that's a little bit smaller. Imagine you wanted to make a 4 by 6 centimeter copy of the original photo. What percent should you use? If we go from 6 to 12, that looks like that is what? So we're going, think about it, we're going from here to here, okay? Or we're going from 8 to 4. That is a reduction. And we reduce, we need to have a smaller percent. In this case, it's got to be 50% or half, right? Suppose the original photo was enlarged by 150%. Okay. Enlarged would be 150 over 100, and that equals what? That would, you could multiply by that, but what we'll get to is this with some reduction would become 1 1/2 or 3/2. So that is an increase, right? So I need 1 1/2. Well, what is 1 of that? You know, if I'm looking at the new length, the length is at the bottom, right? All right. Oh, it says length and width. It has length and height on there. Let's say that we'll keep the length and the length, right? So this needs to be a full length of 8 plus a half of that, which is 4, right? So that would be 12. Now, I could do also 8 times 3 over 2. to get to 24 over 2, which is, there's my 12, right? 12 centimeters. Now I would do the exact same thing for the width, and I would get 18 centimeters. Do that work on your own. You remember that a quadrilateral is a four-sided figure? There are many different kinds of quadrilaterals. On graph paper, draw a quadrilateral with one side that's 12 units, another side that's 9. Then reduce your quadrilateral so the ratio of the sides of the new to original is 2 to 3. So this one's a big jump. I feel like if you can get through this, you're in pretty good shape here. So what we'll do is 12 by 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, and up. There we go. Now, the new to original, I should have had that flipped, I think, rotated. New to original means when we have a ratio like this, the new is, I think we're okay. New to this is the original. So what does that mean? Now, if we remember our 2 to 3 sort of thing, if we have a 2, if I think about a double number line again, going way back, new to original, and I had 0 over 0 here too. What I could do is I can use that 12 and that 9 to get me there, right? So the new, remember we could do 4, 6, 6, right? I'm going to go up by 2s, 8, 10, 12, 14, 16. And my original is 3, 6, 9, 12, 15, 18, 21, 24, right? Okay. So what I have now is if my original was 12, then my new side is 8. And if my original was 9, then my new side is 6. So I need to draw a 8 by 6. 8 by 6, because those are my two new sides, right? All right, so I could draw that 8 by 6 with, okay, 8 by 6. I guess we're going to have some overlap here, right? Probably. So let's do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And we can connect them, can't we? Whoops. Kind of fell off there a little bit. New. Please. Thank you. And this was my original. Okay. Xenia drew the trapezoid shown below. She wants to draw another figure of the same shape, so the relationship between the two figures can be described by a ratio of 2 to 7. What will the length of the longest side of her new shape, right? So in this case, what does she want to do? She wants to draw a figure of the same shape, relationship, ratio 2 to 7. This will be an enlargement. Okay, this will be an enlargement. Doesn't say that necessarily, but usually by ratio 2 to 7, we would say this was the original and this is the new. So what we'll do is we will use, will be the longest side of our new shape, and is there that we just need that longest. So let's find that here, right? That's that length right there, okay? So we're going to count that out, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So I have 14 is my largest. So what I'm going to need to do is make that bigger, right? Oh, no, I just drew. I'm sorry, I did make a little mistake in here. My bad. These should be flipped. My bad. The new one would be 2, and the original would have been the 7. Sorry about that. I just realized that if we multiplied by 2 7s, I don't know what I was thinking there for a moment, but if we multiply by 2 7s, we would expect 2 7s to be a reduction, much like way up here, right? When we did these things, right? 3/4 was a reduction, but something like 1.5 or 2 was an increase. That's how we should view this down here. That 2/7 should be a reduction. It's less than 1. We didn't talk a lot about that, but we're starting to develop that thought process that anything under 1 should be a reduction. So new to original. So now if something were 14, then my reduction should be, it means that I would be smaller than that, right? So let's do a new original. And let's just do a double number line here. 0. So my new is 2 for my original, which was 7. But my original was what? 14. So if I just doubled that, what's my new? My new length is 4. Well, that's quite a bit smaller, isn't it? 2/7 makes that a lot smaller if I go from 14 to 4. Is there more than one possibility for a new shape? Well, I don't. Could you have it larger if you wanted to? If you wanted to say it was original to new, you could write that way, because any ratio can be written in both directions. However, when we see it in this case, without it being told, we want to make it a reduction. You've discovered that when you enlarge a figure, the ratio of the side lengths between the original enlargements stay the same. What about the perimeters? What about the areas? When you enlarge a figure, does the ratio of the perimeters between the original enlargements stay the same too? What about the ratio of the areas? Think about this as you conduct the following investigation. Find the perimeter and area of the rectangle at the right. So the perimeter, add up all our sides, 4 plus 10 plus 10 plus 4 plus 10, right? Perimeter is going to be 28 units. And area equals 4 times 10, which is 40 square units. Draw a new rectangle that has an enlargement of the rectangle at the right, so that the ratio of the sides of the original to new is 2 to 3. So original to new is 2 to 3. Label the length and find the perimeter, the area of the new larger rectangle. Hopefully you start to see how to use do it without a double number line, but I will do it just to make sure that we see this, right? So we have original to new, 0 to 0. There are ways for us to go about this differently. 4, 6, 8, and I only really need to go up to 10 because the original goes up to a side length of 10. So I have 3, 6, 9, 12, 15, right? All right, so let's look at our new lengths, right? If I had a 4, my new length should become 6. And if I had a 10, my new length should be 15. What's another way to do that? Think about this in a little bit different way. So I want you to think about for every 2 in the original, we have 3 in the new. So think about, as we look, this 4 is broken up into 4 pieces, right? So for this 2 in the original, it has to become a 3. It's kind of another way to look at our ratio. So this 2 also has to become a 3 for a grand total of 6. And if we take a look over here, right, which once was 4 is now 6. So what was 10, it needs to become 15. Or will become 15. And we can think about this as in 1, 2, 3, 4, 5. Wait, I'm drawing this way too close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we'll do is there's 2, 4, 6, 8, 10. There they are. So that 2 becomes 3. This 2 becomes 3, that 2 becomes 3, that 2 becomes 3, and that 2 becomes 3. So 3, 6, 9, 12, 15. There's another, that's just a different way to look at it. I'm not saying it's the way that works for you, but it is a way that works. All right, so let's draw the new one. It becomes a 6 by 15, and our perimeter now is 6 plus 15 is 21. 21 times 2 is Oh, I should have gave myself some room here. Give me a second, please. I'll put that up here, and I'm going to just do this. All right. Sorry, 21 times 2, 42, right? 42 units. I just had a thought in my space. Spacing there, area is 6 times 15. 6 times 15 is 90 square units. You can do the math on your own there. And now write the ratio of the original perimeter to the new perimeter. So the original perimeter is 42. I'm sorry, original to new, my bad. So that should be 28 to 42. And then write the ratio of the original area to the new area. Original area is 40. New area is 90. We can reduce these now. 40 over 90, that's easy. That's 4 to 9, right? And then here, let's reduce this. We could divide them both by what? What could we do? Well, we could divide them. We can go faster at this, but I'll just take it a little slow here. We'll divide them both by 2 and get 14 over 21. Oh, I see a 7 in there, so that's 2 to 3. Now, we could take a second and let's do a little comparison up here. What was the original ratio? Ooh, it was 2 to 3. So what did we know about the perimeter? Hey, that ratio stayed the same. But for the area, that ratio did not stay the same, did it? That ratio changed differently. Interesting. Lots of good things to kind of maybe discuss future parts of math there. All right, this is an A-level type question. If you wish, you could stop at this point, but if you want to, you could look at this as just a little extra. Carlos was working with his team to solve the following challenge program. Triangles A, B, and C are shown below. The ratio of the sides of the triangle A to B is the same as the ratio of the sides of B to triangle C. Carlos says the base of triangle B must be 25 because 25 is halfway between 5 and 45. Is he correct? If so, explain how you can be sure. If not, what is the length of the base of the triangle B? Okay, so if this were supposed to be 25, as he said, but they said the ratios are the same. So if I do the ratio of A to B, that's 5 to 25. And I can reduce that, right? Divide them both by 5, get 1 to 5. And I'm going to reduce it because it's easier to compare. So now let's do my comparison, B to C. That's 25 to 45. I divide those both by 5, and I get 5 to 45 divided by 5 is 9. Are those the same? Whoops, my finger got stuck on the edge there. Same? No. Okay, so 25 cannot be the answer, right? So you have to think that we need the same ratio. What could that be, right? What could that be? So I'm just going to draw these over here. And we'll just have A, B, C. And that was 5, and this one was 45. So what is that number, right? So what I need to think about is whatever if I think about a ratio, I need my 5A to B, or 5 to some number has to be the same ratio as B to C, which would be something to 45, right? So in this case, you might see it, and you can do it with some multiplication and some division, but maybe even just a guess can sometimes be the case, right? So let's just try some different numbers in here and see if we can't figure out what that would be, right? All right, so let's just say, let's try 10. Let's try 10. All right, 10. Okay, 5 to 10, that's 1 to 2. And that one we could divide them both by 5 and we get 2 to 9. Okay, not the same one, right? I'm guessing we need to do a little bigger, maybe, than 5. So let's try something different. And let's see if we can't find a different number that would be in there. Let's try 15. 5 to 15. Let's divide them both by 5. I get 1 and I get 3. Then if I do 15 to 45, divide them both by 5. And what do I get? I get 3 to 9. Ooh, I could reduce that even further. Divide them both by 3. I get 1 to 3. Hey, 15 works. 15 works. Now, another way to view that or to look at that, whatever we multiply 5 by to get to b, if as a ratio, is the same number I would need to multiply b to get to c. So 5 times 3 in this case gets me to 15, and 15 times 3 gets me to 45. And for right now, there's some ways to calculate later, but I think just that guessing and checking will be our best method. So if you have any other questions, please let me know.